It worked in nutrition and food for a number of years, but then transitioned into environmental occupational, did some work at the EPA, and decided that it had some real interest in occupational as well. So has taken on this issue of occupational exposure to solvents and shows some construction work to look at. So, Allison.
Thank you, Dr. Michaels, for the introduction. Hello, everyone, and thank you for coming. Again, my name is Allie, Cailliau, close pronunciation. Nobody gets it right, but that's fine. So today I will be presenting my systematic review titled Occupational Exposure to Solvents and Associated Neurotoxicity in Construction Painters. So existing evidence suggests that occupational exposure to solvents can have devastating and adverse effects on cognitive function. Beginning in the 1980s, people were becoming more aware of this issue and how it might be affecting workers' health, specifically those in the construction industry, that they are often chronically exposed to harmful chemicals such as solvents on a daily basis. A solvent is defined as a liquid that can dissolve, suspend, or extract other materials without chemical change to the solvent itself. And despite their known harmful effects, solvents are still used in a wide range of industries today, including construction, engineering, dry cleaning, printing, manufacturing, and many others. It's estimated that 49 million metric tons of solvents are produced annually in the United States, and about 10 million people are exposed on a daily basis. So this is a very important public health issue that we need to address. Some long-term health effects of solvent exposure include nervous system damage, kidney and liver damage, reproductive organ damage, skin lesions, and cancer. I chose to focus on the outcome of nervous system damage, otherwise known as neurotoxicity, because it had a sufficient amount of existing literature, and I thought it was the most interesting. So to begin the review process, I created what is called a PICO statement to better focus and narrow down my topic. We all kind of know what this is by now, but my population, again, is construction painters, which is defined as someone who applies paints, stains, coatings to walls, buildings, bridges, or other structures. The exposure of interest was occupational exposure to solvents that are present in the paint. Comparator group or control group is workers not exposed to solvents. And again, the outcome is neurotoxicity, which includes symptoms of neurological decline, neuropsychiatric disorders, and decreased cognitive function. And to the right are just two common solvents, xylene and toluene, that are used in construction, so I thought I would throw in the visual for those who appreciate that. So to conduct my systematic review, I followed the basis of the navigation guide, which again, we all know what that is now. It just includes 4 major steps. Again, to specify the study question, which is the PICO statement. Second is to select the evidence. Third is rate the quality and strength of the evidence. And fourth is to grade the strength of the recommendations. So beginning with my study selection, I conducted a systematic search of the literature in 2 databases to keep the review process relatively simple. Those were PubMed and Scopus. Once I compiled a large list of articles, I screened their titles and abstracts for relevance to the review topic and chose appropriate records based on my inclusion criteria, which I will discuss a little later. Overall, I included original studies discussing occupational exposure to solvents as a construction painter that reported associations with symptoms of neurotoxicity. And to the right is just a table showing my search terms for the Scopus database, as well as the limits, which I limited my search to, which were human species only, English language, and journal articles. So after initial screening and selecting the appropriate records, I assessed each included study for risk of bias using the navigation guide's instructions for making risk of bias determinations, which is comprised of 8 domains, starting with recruitment strategy up at the top and going down to conflict of interest at the bottom. Basically, I assigned a rating of low risk, probably high risk, or high risk to each domain of each of my included studies, depending on what I thought was most appropriate. So focusing, yes, okay, well, that's fine. Focusing on the confounding domain as an example here, here's what assessing the risk of bias looked like for one of my included studies. I ended up giving this a probably high risk rating because the authors only adjusted for self-reported alcohol intake and did not comment on if they controlled for other confounders, so that was unclear, and I thought that might have impacted the study results in a negative way. So next I assessed the quality of evidence using the grade approach, which is just a formal process designed to rate the quality of scientific literature. A rating of either high, moderate, or low are the 3 options to assign to the overall body of evidence based on downgrading, upgrading factors, which I will discuss a little more later. And the strength of evidence was based on 4 categories developed by IARC, the International Agency for Research on Cancer, and those either range from sufficient evidence as the highest down to lack of evidence as the lowest rating. So moving on to results now. This is the flow chart of my study selection. Starting over at the left, I started with 241 records identified through my 2 databases that I searched, and quickly narrowed that down to 207 after duplicates were removed. And of those 207 articles, I screened their title and abstract, and excluded 184 of those for reasons including irrelevance. A lot of the articles that came up in my search weren't actually relevant to my topic at all. Also non-human subjects, unspecified occupation, and if the population was not construction painter. A lot of articles also had populations like spray painters or automobile painters, which wasn't exactly what I was looking for. So at that point, I had 23 full-text articles that I again assessed for eligibility, excluding 16 of those for a different health outcome other than neurotoxicity. I wasn't sure at this point if I wanted to focus on cancer as an outcome or neurotoxicity. I picked neurotoxicity and got rid of all the cancer articles, and also if exposure to another type of chemical was discussed. A few articles talked about lead and things that weren't solvents. So in the end, I had a total of 7 studies included in my review, 1 case control, 1 prospective cohort, and 5 cross-sectional studies. So this is the risk of bias heat map that provides results for each domain of my 7 included studies. As you can see by looking at the map key in the upper left and comparing it to the heat map, there was an overall low risk of bias for each included study, as well as across studies as a whole. The darker color represents probably high risk ratings, which I gave to a few articles in the exposure assessments, confounding, and other bias domains. So this table presents the results of the quality of the body of evidence. As you can see, the evaluation factors on the left include 5 downgrading factors and 3 upgrading factors. So taking a closer look, I gave a downgrade rating of -1 for risk of bias because some of my, 4 of my included studies had some type of risk of bias. Whether it was extreme or not, it was still present, so I thought that deserved a downgrade rating. Additionally, for inconsistency, 6 of my 7 included studies did show consistent results that with increased solvent exposure, increased symptoms of neurotoxicity were present, but 1 of them did not have this association, and just they explained that the study participants self-reported more symptoms of neurotoxicity rather than it actually being a result of the study. And on the other hand, for upgrading factors, I gave a +1 for large magnitude of effect seen across all my studies, as well as dose response, as there was a dose response relationship present in 1 of my 7 included studies. So overall, I gave a rating of moderate to the quality of the body of evidence. And next is the results of the strength of evidence. So looking at this, it really is an important public health issue that we need to address. Some future research efforts should focus on identifying vulnerable populations with past and current solvent exposure, specifically focusing on the cumulative dose as well as the amount of time exposed to better understand the effects in terms of intensity of outcome and chronicity. Also, focusing new studies on other working populations or industries that may be equally at risk is important because, as I said, construction workers aren't the only people exposed to this, so maybe conducting new studies with dry cleaners as the subject, or maritime workers, which is just shipyards and ship workers, or manufacturing. This would really benefit the area. And also, it's just important to conduct studies with large sample sizes and robust exposure assessments if possible. Cross-sectional designs, which a majority of my studies were, and as a few other people pointed out, they're okay, but they're not the best. They can lead to misclassification from recall bias if the participants can't remember what solvents they were exactly exposed to, the amount of time, and so on. And evidence also of the healthy worker effect, which just states that the working population tends to be healthier than the general population, but if workers are already too ill to be at work, then they won't be included in the study because they're no longer employed. So overall, long-term follow-up studies such as cohort studies are most ideal for this exposure and this outcome. And in conclusion, there is sufficient evidence supporting the association between occupational exposure to solvents and neurotoxicity in construction painters. We really must take this existing evidence into account and begin to take action to protect our workers. Some things that can be done. OSHA has some some outdated standards for common solvents. I just recently looked up a few, and they have updated some within the last decade, but there are others that could use revising, and that would, I think, help out a lot of industries. And also, employers can help minimize daily exposure for their employees by implementing and enforcing the hierarchy of controls. It's especially important for smaller construction companies or contracting companies to be trained and educated in how to do this properly. So for those of you who are not familiar, the hierarchy of controls is over here to the right. And it first starts with elimination, physically removing the hazard. This is the most effective solution, but it is not always possible. So the next best thing is to substitute or replace the hazard. So we would ideally replace the solvents for safer chemical options. Next down the line is engineering controls, which involve isolating people from the hazard. These are actually very effective and make physical changes to the workplace, such as installing ventilation systems or fume hoods. Going down now to the least effective options are administrative controls. They change the way people work. They help reduce individual exposure time by maybe rotating job assignments or allowing only certain people to handle the toxic solvents. And lastly, at the bottom of the list, which most of us are familiar with, is PPE, or personal protective equipment. This is the last resort, but in situations like this, a respirator or gloves would be appropriate. But as Dr. Michaels often says about other exposures to chemicals, the solution really can't just be to use respirators. They should be worn in construction sites and jobs like this, but they're very hard to enforce the use. People don't want to wear them, they're uncomfortable, they're bulky. It's not something people want to wear for 8 hours of their day, especially if it's hot outside or if what you're doing inside is hot. And also for men, it's more of a problem because their facial hair can break the sealed protective barrier of the respirator, so they have to shave all the time, which is annoying, so it's not something people really want to rely on. But nonetheless, it's still important in the overall hierarchy. So, reducing and preventing exposure to solvents is possible, I believe, with the right practices put into place and proper adherence and cooperation by the workers themselves. Employers can, they can go so far, they can train and educate, implement new practices or laws, but the workers really have to want to protect their health and well-being themselves. So it really is a joint effort between employers and employees. And with that, I would just like to thank Dr. Michaels for being a wonderful CE advisor through this and last semester, Dr. Price as the CE course instructor, and all the EOH faculty and students. I really don't think I would be here doing this without your support, so thank you very much. Any questions? Yes?
Great presentation, thank you. I'm just wondering, what did the studies that you looked at, was there quite a bit of range in terms of the amount that they were exposed to and the duration?
Yeah, they were all kind of different here of it, but they didn't always say like the actual amount, but the way that they measured solvent exposure was mainly through questionnaires, self-reported intakes, and one of the studies actually used a personal air monitor that the workers would wear for like an extended period of time during their shift. But yeah, they all did vary a decent amount. So.
Did they talk about the different types of solvents at all? This was a very great presentation too. Sorry,
Thank you.
I'm trying to remember my question, but I really enjoyed it.
Honestly, not really. They didn't specify the types of solvents in the studies that I read. They just kind of quantified it as solvent exposure. Some had like solvent exposure with other things, like with lead or with something else, but they didn't exactly say what types of solvents. That's why I looked up a couple weeks ago what types are actually used in the construction industry, and I've got written down here somewhere else. So. But yeah, the ones I mentioned on the screen, toluene and xylene, are common, and something called mineral spirits, which are like basically just paint thinners. They use that a lot in construction painting. So.